Hi, my name is Cameron Akbarzadeh, and this is the third lab for physics, black hole orbit. The purpose of this lab was to calculate the mass of a black hole by using data from a star's orbit around a black hole. The mass turned out to be 2.9852 times 10 to the 31 kilograms. For this lab, we had to use Newton's second law in the form of F net equals delta P over delta T, derived from the dP dt equation. Then, we use Newton's law of universal gravitation, which is the gravitational constant times the masses of the star and the black hole divided by the distance between the two systems, the star and the black hole, squared. First off in the code, I place initial conditions of the star's mass of 1.989 times 10 to the 30th kilograms, the position of the black hole, which was a vector 4 e to the 10 negative 3 e to the 10 0, the gravitational constant, and a time step of 86,400 seconds, which is also the equivalent of 1 day. Next, I put in code that would find the x and y components of velocity. And after the code was manipulated to find the change in velocity and change in momentum. After that, dp dt was found by using delta p divided by delta t. And then we set F net equal to dp dt. From there, we differentiate the different types of F net and dp dt with the parallel and perpendicular components, all by using Newton's second law. Here's the code when it's run by Vital. As you can see, the yellow arrow, or F net, pointed to the black hole, which in this code turns out to be yellow. F parallel is the black arrow and F perpendicular is the blue arrow. And we see that the star is in the black hole's orbit as it goes through it. After this, the code prints out F net, F parallel, and F perpendicular. Notice that the values of F parallel and F perpendicular equal F net. Then the code printed out the mass of the black hole, which was 2.9852 times 10 to the 31 kilograms. So then, how would you be able to differentiate between F net and dp dt? Well, dp dt and its components set the motion of the star and are qualitative, while F net and its components affect the motion of the star and are quantitative. If the black hole was removed and a different black hole was placed in the same location, you couldn't tell the difference since the motion of the star is unchanged. In addition, all the values you used before to find the mass of the first black hole would remain the same, only if the star is affected by the gravitational force. All of this means that the mass of the black hole would remain the same. Thank you, and this was Lab 3.